So we have, let's say, just give an example like 3 by 2 and 2 by 1. As we said before, if I have 3 by 2 and 2 by 1, I could multiply those two things because of these two numbers are same. And the result that I will get is those outer points 3 by 1. So what I'm trying to say is when I multiply something like 1 minus 1, 1, no, 1 minus 1, 2, 0, 3 minus 1, something like this, and multiply 2 minus 1 and 2, 2 by 1, then I'm going to end up with something like this, right? And we do that by calculator, but let me just briefly show you what to do here. You're going to get 1 and 2 over there. Those two numbers multiplied, added together will be my first one. So 1 times minus 1 plus minus 1 times 2. That's going to be my first number on the top. Second number is coming from here and there. So minus 2 times minus 1 time plus 0 times 2. Last one is that and that. So we get 3 times minus 1 plus minus 1 times 2. Done. So we add it all together. What do we get? Minus 1, minus 2, minus 2, and minus 3 minus 2. So at the end we get minus 3 minus 2 minus 5. Okay, so if you know how to do that, that's great. Moving on, I'm going to give you guys some questions on, well, there's only one couple questions, 146 and 147 as homework to do. And then let me talk about determinant. So every matrix, not every matrix, but n by n matrix, square matrix, have something called determinant. So n by n. So rows and columns have same numbers, right? So something like 3 by 3. So 1, 2, 3, minus 1, 0, 1, minus 4, 1, 5. Something like that. This one will have something called determinant. And you can see that on your book. It talks about how you can find the determinant on the bottom of page 147, right? But they give you an easy one. When you have 2 by 2 2 by 2 matrix, it's easy to find the determinant is A, B, C, D when you're given this thing right here. The determinant of that thing is just number AD minus BC. Example. Let's do a big number. Something like this, right? So if I have that, I could have determinant of that by looking at that minus that. So 100 times 7 minus 1 times 5. So we will get 700 plus 5, which gives you 705. So there's how you find the determinant. And it's just waste of time if you try to find determinant of the 2 by 2 using a calculator, right? So use your hand to find that out. And when the determinant of any n by n matrix is not equal to 0, you have an inverse. What I mean by that is, okay, this one is determinant is not 0, right? Which means I could erase this part right here. In a square matrix, if the determinant is not equal to 0, in this case right there, 105 minus 17, then I could come up with another 2 by 2 matrix with some numbers in it, so that when I multiply them together, I end up with my identity inverse. We call it I. It's working like 1 in real number. Whenever you multiply any number to 1, you still get that number, right? Or when you're multiplying 5 to 1 over 5, if you multiply them together, we get 1, right? So we call these each other multiplication.